Good evening to all. I'm Pranav Nair, and today, me and my teammates are going to present on a topic, a situation in an electric scooter company, case study conducted at VIIT. The first question which we have come across was that the company wants to do an analysis of the electric vehicle app and what it needs to improve it. Mind map the top 10 features you would want in the app for the electric scooter and explain which are the top 5 features which would be most useful and why. According to us, the top 10 features which we think is essential are the anti-theft and security features, GPS navigation, battery health monitoring system, voice control or voice assistant, ID verification, eco impact tracker, safety alerts and weather integration, maintenance and diagnostical alerts, real-time tracking, and emergency countermeasure system. Out of these top 10 useful features, 5 of them seemed more useful, such as anti-theft and security features. In this section, we can add remote locking system and notification which would inform the user that the scooter is being tampered with. In safety alerts and weather integration, it would be very vital for the users to know about the current weather conditions so that they can plan their trips accordingly. For the emergency countermeasure system, let us say that the user has suffered an accident or is experiencing a heart condition and he needs immediate help. With the built-in crash or fall-off detection, that is, if the scooter is in a tilted state for more than 3 to 4 seconds, it could send an SOS signal, and after pinpointing the location of that SOS signal, emergency services would rush to that location and take care of the patient, potentially saving his life. Real-time parental tracking. Having a system which could track the location of a e-scooter in real time is actually helpful. It helps the parents to know where the child has been and can also aid in its recovery in case it is ever stolen. And maintenance and diagnostic alerts. While implementing this feature, it would enable the app to monitor the mechanical health of the user's e-scooters, such as tire pressure, brake performance, etc. Moving on, what are some of the design considerations you would have for designing the storage feature? And what all will you need to consider for security of the documents while designing the architecture? For design considerations, we can implement a unique account ID per user so that we can ensure that the data is isolated and properly associated. For cloud storage platforms such as Amazon S3 and Google Cloud can be integrated since it is reliable and scalable. We can also enable read-only access on dashboard, which prevents accidental changes while riding. We can also enable access from any device. That is, it enables cloud-first design with backup and recovery. For security considerations, end-to-end encryption is recommended since the data is protected during upload or download. And AES 256 encryption is recommended since it is the industry standard for strong data protection. In access control, only authenticated users can view files. We can also add biometric or OTP login to add an extra layer of security. And as I mentioned before, the read-only mode and vehicle screen prevents tampering or misuse.
Myself, Yashwant Kharab, and the third question is list the potential reasons for any two of the issue which the customers have complained about and write the test scenarios you would use to test. So, some issues from the customer complaints are like quick draining battery. That is, the battery life is very short, so we have to improve the battery draining. And the next one is toxic gas emission. Uh, Toxic material and flammable gases are released due to the decomposition of battery material. So we should also working on that. And okay, next point is we have conducted two test scenarios. One of them is this can be achieved by using multi-mode energy consumption analysis. And our aim was that to evaluate power consumption for our different driving modes. And procedure was like operate the vehicle in eco, normal, sport mode under consistent temperature conditions. So monitoring metrics are like a battery discharge rates, energy consumption per hour, impact of regenerative braking in each mode, and expected result of organizing for modes should have the lowest energy consumption with a progressive increase in normal and sport mode. So that was our first test case scenario. And the second was and the aim of the second scenario was to analyze thermal runaway initiation and propagation with an EV battery model. So procedure was fully charged EV battery. We have taken fully charged EV battery, placed in a controlled environment and make single fail initially fail due to methods such as overcharging, heating, and mechanical damage. So metrics was monitoring metrics was like time propagation, peak temperature, gas emission, structural damage, safety measure, effectiveness. Okay. So our expected outcomes like rapid temperature escalation, sudden drop in voltage, emission of flammable and toxic gases. So this was our second test case scenario, and our expectation get occurred. So second question is that's fourth question that is the inside out and outside in technique of releasing a product to the market and list the top five things you would do in inside out planning to release the new app to the market and the outside in planning for releasing the new app. So the first approach or the approaches for insider planning or like alpha testing, internal testing by employees to catch bugs. So we have a development team or employee team to fix the bug whatever in the software part. So another one is beta testing, releasing to hundreds selected users for real world feedback. So we have select 100 real world users. So we take feedback from them and just apply on our product. And another one is bug fixer and improvements. That's I said that alpha testing and beta testing is what feedback is concluding in bug fixer and improvement approach. And another one is employee training. Train support staff, prepare facts, videos, and chatbot. And another one is internal documentation, create manuals and system knowledge bases. So these are this was inside out planning approaches. So the next like outside in planning, customer first approaches for outside in planning like a marketing plan. We use social media and YouTube influencers for our marketing schemes. And another one is soft launch, early access to select cities or loyal customers. That is also approaches for outside employment. And another one is App Store rollout, publish app with strong visuals and demo video. So this is one of the main approach. And another one is feedback loop, collect real-time customer feedback and fix issues. So this is also our approach for feedback loop. We collect feedback from the users and just improve our product.
Good evening. My name is Indranil. I would be explaining the next two questions related to the topic. Today, we are diving into the critical operational challenge our company is facing. We are collecting vehicle data in the cloud, but experiencing performance issues during data collection, cloud synchronization, and app updates for end users. The big question we are tackling today is what's slowing us down and how can we fix it for the seamless vehicle to app data flow. We'll break this down, analyze the cause, and explore actionable solutions. Next. Let's first look at what's actually causing the performance lag. Here are top 5 bottlenecks. Weak network signals. Vehicle location affects data upload speed and consistency. Second, poor data structuring. Backend APIs might be handling bulky or poorly organized data. Third, communication delay. There's latency from vehicle to cloud and then from the cloud to app. Then the another reason could be no real-time sync. The app sometimes reflects outdated data. The fifth reason is insufficient backend resources. Our servers may be under provision for high volume data. Each of these areas is adding drag to our data pipeline. Next, now here's how we could tackle these challenges head on. First is we could adopt efficient protocols. Lightweight protocols like MQTT offer fast, reliable data transfer with minimal overhead. Second, implement edge computing by processing key data on the vehicle itself. We reduce load on our network and cloud. Then third, optimize backend architecture. Clean APIs and compact data packets could improve cloud processing speed dramatically. Enhance cloud capacity. Auto scaling infrastructures ensures our backend keeps up even during high demand. Use real-time sync tools. Tools like Firebase or Redis help keep the app continuously updated with fresh data. To sum it up, for seamless integration from vehicle to cloud to app, we need to think light, think local, think real time. If we optimize each layer from signal strength to backend scaling, we'll deliver a smarter, faster, and more responsive ecosystem. Next, in the second question, let's see what it says first. Let's shift gears and talk about the next generation vehicle we are planning. The goal here is to build a product solution mind map covering our business goals, feature set, UI UX upgrades. We want to launch ready blueprint that guarantees market impact and customer delight. Next, our core business and product goals include business boosting customer satisfaction through smart features, reaching hashtag 2 market position within a year, achieving 50% sales growth in first 6 months, securing 10% profit per vehicle, balancing cost and innovation, ensuring a zero critical issue launch for the long term trust. These goals will guide every decision we make in product design. Next, now let's talk about the must have features for this vehicle. Fast charging under 4 hours, lightweight frame for better efficiency, touchscreen dashboard with built-in Google Maps, in-app documents, uploads and dashboard control, smart battery management, multiple ride modes like eco, power or city mode. Each feature is engineered to meet customer needs while standing out in the market. Let's not forget the experience, the user experience and user interface. Our make or break UX upgrades include voice or touch ride mode switching, predictive maintenance alerts, streamlined app layouts, UI upgrades. We can include UI upgrades such as color coded, clean dashboard design, gesture control, auto dark or light mode based on lighting conditions. It's just about functionality meeting aesthetics. Um, that's it for from my side. Ram would be continuing.
Good evening. I am Ram Chavan. So the question is research on the evolution of the domain of electric vehicles and representation it on one slide in an impactful way on what has been the evolution and where you think it will be in next 10 years from now and what kind of features functions would be available. How has the technology evolved and what is the future direction of this technology? Next, evolution of electric vehicle in India. So the first electric vehicle was invented in 1996, which was three-wheeler from 2000 to 2007. Much of other Ace automobile brands that launched a series of electric scooters and bikes. Then from 2005 to 2015, most EV companies were sold out, leading to a period of in the industry named 2015. In 2015, signs of a slow yet sure EV industry induction among India consumers, starting with e-rickshaws, especially in the NCR region. Then from 2016 to 2017, with government support, more than 5 lakh e-rickshaws were sold in Delhi, Punjab, UP, West Bengal, Bihar, and in Haryana. Now, for future from 2025 to 2030, the number of electric vehicles sold annually to reach 4.2 million units in 2025 from 1.05 million in 2022. This will leading to a massive growth of vehicle sales between 2025 and 2030, taking annual sale of taking annual sale to 15.3 million in 2030. Next, future direction of EV technology, AI and AI and IoT integration. AI is one of the major technology trends dominating the current market. In the future, there is a high chance that we might witness the EV segment warming up to the Internet of Things, and IoT integration will not be just limited to the premium segment, but will also occur at the services level. Both AI and IoT can help the industry understand and monitor riders' daily consumer and suggest charging cycle. Then non-lithium ion battery powered vehicles. Lithium ion battery is an advanced battery technology that uses lithium ions and the basic and main component. Keeping pace with the rapidly evolving EV industry, the battery chemistry is also advanced. Many battery technology startups have already developed batteries that are compatible with the Instacharge stations. Several companies are also developing graphite battery run electric scooters. Next, smart charging. Like conventional chargers, smart charging and can communicate with the vehicles and the grid to provide better cost for energy consumption. It also promotes better use of energy with smart charging technologies. People can decide to go for charging via renewable energy, which will lower the CO2 emission and reduce energy traffic. Then load balancing. Load balancing can also be supported by smart charging, especially as energy demands on the national grid increase alongside sales of electric vehicles. Load balancing is a growing technology trend that helps distribute the available capacity over all active charging stations. It also helps ensure that optimal charging is provided to all electric vehicles at a specific location within the limits of the charging station's capacity. With this technology, uh, charge point owners will be able to balance the load and distribute the current between units. This is dynamic, cost-effective, and much more sustainable way to send energy to every single station. Next, next question. If you want to write detailed test scenario for testing the battery of the vehicle, what all would be the top 10 to 20 scenarios? Create a mind map and do a relative priority of the test scenario based on most important to least important. So prioritize list of testing scenarios for testing the battery of the EV. So here are some examples like battery life, durability, temperature testing, high temperature testing, low temperature testing, water testing for rainy season, battery capacity, charging time, fast charging, battery leakage, proper connection testing for then overcharging protection, vibration testing, and then thermal runaway protection. Next, thank you.